everyone, this is Riyasat from Roots Academy. Today we're going to discuss about projectile motion, and this is a lecture on A-level physics. First of all, let us ask, what is a projectile? A projectile is an object which has a velocity v0 with an angle with a x-axis theta naught. So it is actually directed to an angle. It has a two velocity in two direction. One is a velocity in x direction. This v0 has a component on x direction and in y direction. So when it is traveling, it will travel in x direction as well as y direction because it has two components. Let us see what are the components are. First of all, this v0 has an angle theta naught with the x-axis. So that's why the x component of this velocity is v0 cos theta naught. This is our initial velocity in the direction of x-axis, so we can call it vx naught. Next, we can see there is a y component of this velocity v0. So this v0 has a y component, so you can write it down like vy naught equals to v0 sine theta naught. So these are the initial velocity and the components of v0. So as it is the initial velocity, we can say there is time is equals to 0. So this is our initial assumptions here. So there are more assumptions, like we can assume that there is no acceleration. There is no acceleration in the direction x because we are not considering any air resistance in this direction. So we can consider there will be no acceleration in the direction x. Now the second assumption is there would be a gravitational acceleration in the y direction. So this gravity is acting on y direction, which is opposite to the initial velocity vy naught, because vy naught is acting upwards and the g acceleration is acting downwards. So these are initial assumption of a body which is in a projectile motion. After this, we're gonna find the maximum height of this projectile, the maximum range of the projectile, the time of flight of the projectile, and the time requiring to achieve the maximum height. So we're going to do it on the next section. Now we are going to calculate the maximum height of this projectile. So let us think this is our maximum height at point A. So at point A, we're going to get the maximum height, which is we can write down as h. So h would be our maximum height. So if we draw a tangent here at the point A, we can find the direction of the velocity of the projectile, which is v, and we can see that this angle is actually a 0 degree angle. So from this we can say that vy is equals to v sine theta, which is v sine 0, and that will give us the velocity 0. So the velocity in the y direction would be 0 here at the maximum height, because the angle is 0 degree here with the point A. So this is our first assumption to find the maximum height, where the velocity in the y direction is 0. So from the formula, we know that h equals to vy naught t minus half of gt square. This is the formula we know. Another formula we know is vy square equals to vy naught square minus 2gh. So these two formulas actually, which formula we should take? This is the question. The first formula, we can see that t is unknown here. So we're gonna use this second formula, which is vy square equals to vy naught square minus 2gh. So here we can see that vy naught is actually v naught sine theta naught, and vy square, actually this value will give us 0, because at maximum height the velocity is 0 in y direction. So from this equation we can find and calculate the maximum height. If we factorize this, we can get h equals to vy naught square by 2g, and we can see that vy naught actually v naught sine theta naught. So the maximum height h, we can say this x max v naught square sine square theta naught by 2g. So we can formulate from this equation the maximum height of a projectile. So we can get now the maximum height. So next up, we're gonna find the time required to achieve the maximum height. Now we're gonna find the time for maximum height. So here again with the same assumption that at maximum height the Vy, the value of Vy, which is V naught sine theta naught, actually would be 0. So from our formula we earlier know that Vy equals to actually Vy naught minus Gt. Why minus? Because the G is actually acting downwards and the motion Vy is actually upwards. So here, from here we can find the T, the time required for achieving maximum height. So here we can see Vy equals to Vy naught minus Gt. So here again Vy naught, Vy actually 0. So we can get the value T actually Vy naught by G. And what is Vy naught? This is actually Vy naught, which is V naught sine theta naught. So the time required for achieving maximum height is nothing but V naught sine theta naught by G. So this is our second formula and we have derived it and the relation actually established. So next page we're gonna find the maximum range of this projectile. So to find the maximum range, we actually, what is range? The range is the maximum distance traveled by a projectile in x direction. So this is our range R. So this range actually in this direction the velocity is acting actually V naught cos theta naught, and as there is no acceleration in x direction, this velocity V naught cos theta naught would be constant in all the time. V naught cos theta naught would be constant. So to find this R, we actually know another term, which is the time of flight. We actually want to know the time of flight of this projectile. So at first we're gonna find the time of flight of this projectile. So how can we find it? So we can see at this point A and B, the height is actually 0. This height is actually 0, and h equals to 0 at time 0 second, and another time would be the time of flight. After the time of flight, the projectile gonna hit on the ground and it will stop at the point B. So this is our assumption that height would be 0 after the time of flight. We know that h equals to Vy naught t, capital T for time period. And what is Vy naught? The initial velocity in the y direction. When we calculate height, we are always going to take the velocity along y direction minus half of gt square. Here t is the time period. And after from our previous assumption, we can say that h would be 0 when t is equals to the time of flight. So here the h is 0. So assuming this, 0 is equals to Vy naught, which is V naught sine theta naught t minus half of gt square. So from here we know this is a quadratic equation. So there must be two solutions of t. But here we can see that we already know one solution. What is this? This is h equals to 0. So h we can find 0 at the time of 0. So at initial time the height of this projectile would be 0. So we know one solution. So we don't need to solve this quadratic equation. Instead we're gonna make this equation a linear equation. So we can take this t out of this quadratic equation and we can take common and find that t v naught sine theta naught minus half of t gt equals to 0. So we're gonna cancel this t out because we know that one solution is t equals to 0. Then we can get the t time period actually 2 v naught sine theta naught by g. This is our time of flight. So we're going to find another formula which is time of flight. So from this we're going to calculate the range of the projectile. So we can say that r is equals to, we can write like this, r is equals to velocity in x direction, initial velocity in x direction into the time period Vx naught into t. So Vx naught t is actually the range of our projectile. So why there is no acceleration? Because this part here is actually 0, because in x direction there would be no acceleration occur and there is no air resistance. So we can write it here, that relation between R and T, Vx naught into T. So R equals to V naught cos theta naught, and the value of T we can already calculated is actually 2 V naught sin theta naught by G. So you can do a little trigonometry here. So here we can have V naught square into 2 sin theta naught into cos theta naught by G. And from trigonometry we know that sin 2a is actually 2 sin a into cos a. So we can write this actually in the form of this equation. So we can get R equals to V naught square sin 2 theta naught by G. So this is our range. So the formula of range. Then what about finding the maximum range? How can we calculate the maximum range possible? So we're gonna actually look at this equation. This is R is a function of V naught square sin 2 theta naught and G, where V naught square actually a constant. This value is a constant and G is also a constant. So this function, this range is actually entirely dependent on this function of sine. Then we can conclude sin 2 theta naught. If we get sin 2 theta naught, the maximum value of sin 2 theta naught, we can get the maximum R. R will become maximum. Then how can we get the maximum value of sine? We know that sine, the maximum value of sine is actually plus 1. So from this we can establish that sin theta naught 2 theta naught is actually 1. When it becomes 1, R will become also maximum. So theta naught 2 theta naught actually will become what? Sine inverse 1, and this value will give us 2 theta naught is actually 90 degree, and the theta naught will become 45 degree. So this is the condition for maximum range. So when we throw a projectile with an angle of 45 degree, it will travel the maximum distance in x direction. So the maximum R max would be V naught square by G. So thanks all. So we're gonna find these formulas today. So hope you guys enjoyed it, and thanks everyone for watching this video.